Hi everybody, hope you're having a great day today. We are going through section 3.3. We're graphing some quadratic functions again. This time we're graphing them when they are in this format right here, which we'll talk about during the video. It's called standard form. So that's what we're up to today. I will let you guys go through the starter on your own, so pause the video, do that, and then unpause when you're ready to move on. Alrighty, so number one on the notes. I showed this same screen in our last set of notes, but here it is again just to remind you. We study three main forms of quadratic functions. Vertex form, that's what we learned about last lesson. Standard form, that's what we'll learn about this lesson. And intercept form, that's up for next lesson. So that's kind of where we're at in the chapter. Number two, write down the standard form for a quadratic function and talk about how to graph some of the key parts of a parabola using this form. Here is the standard form for a function, or for a quadratic function, ax² plus bx plus c. The a and the b and the c number will of course be mixed up, and there'll be various numbers according to the examples and the problem that you're doing. It's pretty straightforward. I think we learned about this earlier. It's called standard form because the exponents go down each time. If you have a quadratic function that starts out in standard form, you can still graph it. It's maybe not quite as easy as when it was in vertex form, but it still works pretty good. To find the x-coordinate of the vertex, here's the formula. You do negative whatever your b number is divided by 2 times whatever your a number is. That'll give you the x-coordinate of the vertex of that parabola. The axis of symmetry will be the line x equals, and then, oh, look at this. It's very similar because the axis of symmetry has to go right through the vertex. So it'll be the line x equals negative b over 2a. Remember, when it's an x equals some number line, that means it'll be a vertical line, which is what our axis of symmetry is. And then the y-intercept, this is the nice part about standard form, is it's really, really easy to see what the y-intercept is. It's just whatever that c number is, that's the y-intercept. So now let's try some examples of working with these quadratic functions in standard form. So example one, we don't have to graph it yet, but we are finding the axis of symmetry, the vertex, and the y-intercept of the function. So just from habit over the years, I always like to start with the vertex. You know, it's the most important part of a parabola. So I always like to start with that. From the formulas that you just barely wrote down, the x-coordinate of the vertex is negative b, so that would be negative 24 over 2 times the a number. So 2 times negative 6 would be negative 12. That simplifies to be a positive 2. Now that we've got the x-coordinate for the vertex, we just need to find the y-coordinate that goes with it. So of course what we do is we take the x-coordinate and we plug it in for all of the x's. Now you're welcome to do that by hand or on a calculator. When we do standard form, I usually end up doing it on a calculator. It's kind of easy to overload your brain and try and think of this whole big equation all at once. So I'd plug it into my calculator. I plug it in exactly like that, just how I wrote it. When I plugged it into my calculator a few minutes ago when I was doing this, I got a positive 4. So the vertex is 2, 4. The axis of symmetry, doing a little abbreviation there, would be the line x equals, and then remember that's still the negative b over 2a, so it'd be x equals 2. If you're doing it right, your axis of symmetry should always go right down through your vertex. And then the y-intercept would just be whatever the c number is, which is negative 20 in this case. So really just putting those formulas that you just barely wrote down to use. Let's go on to example 2. Let's actually graph one now. So here is our function x squared minus 2x plus 2. Same process. We're going to find the vertex first. The x-coordinate of the vertex is going to be negative b, which if our b is already negative 2, if we have negative of negative 2, or the opposite of negative 2, it would be positive 2, over 2 times a. Well, our a number is just a 1 in this case. 2 times the a number would be 2. So the x-coordinate of our vertex is 1. I went ahead and plugged a 1 in for all the x's on my calculator, and it gave me 1 for the y-coordinate. So we know the vertex is 1, 1. The axis of symmetry is just the vertical line x equals 1. And you can draw that in on your graph. It's kind of nice to have it on there. There's the vertex so you can see it a little better. And last but not least, the y-intercept would be whatever the c number is right there, so it's 2. It's nice having that y-intercept because then you can just use symmetry and get another point on the graph, and you can make your parabola right then and there. So there's an example of graphing something when it starts out in standard form. Here's another example, example 3. Maybe a little trickier just because of that fraction, but we'll go through it basically with the same process. We want to find the vertex first. And let's see, it'll be negative b, which would be a positive 3, over 2 times the a number. 2 times negative a half would just be negative 1. So it'll be negative 3 is the x-coordinate of our vertex. On my calculator a couple minutes ago when I did this, I stuck a negative 3 in for all of those x's, and I got out a positive 1/2 for the y-coordinate. See how this might be tricky just to try and do in your head by plugging in a negative 3 there in your brain? That's why I really like to do it in the calculator. So our vertex is negative 3, 1/2. Axis of symmetry would be x equals negative 3. And it'll be that vertical line going straight down through our vertex. The y-intercept would be negative 4. It's just whatever that c number is. 1, 2, 3, 4. Use symmetry to make that last point. Did I do that right? 1, 2, 3. Yeah. And then we have our parabola. As always, it's a little, oh gosh, This darn tablet that I use, it's hard to draw those shapes for some reason. Hopefully your parabolas look better than mine do on this tablet. But anyways, there's another example of how to go through the process and graph that from standard form. Like I said, I enjoy vertex form a little better. Standard form works just fine too, though. Okay, on to number 4. Talk about maximum and minimum values of quadratic functions and how to find them, then do an example or two. The instructions then would be tell whether the function has a maximum or minimum value, minimum, that should say, there's a typo, then find it. Negative 5x squared plus 10x plus 7. That's our quadratic function here. So, first thing to think about, is this a smiley face parabola or a frowny face parabola? Well, that first number is negative, so we know it's going to be a frowny face parabola. That means it's going to have a maximum value. It doesn't have a minimum value because on each side of this parabola, it'll just keep going down and down and down forever. But it does have a maximum point, which is right there. So this thing definitely has a maximum point. Then we're supposed to find that point. Well, you've probably already thought about this and you've probably been saying it, but that maximum point, it's just a fancy way of saying, hey, find the vertex. Hopefully you agree that that maximum point would have to be right smack in the middle of that parabola, which would be the vertex. So whenever something asks you to find the maximum or minimum point on a parabola, just remember you're just finding the vertex. So the x-coordinate of the vertex would be negative b over 2 times the a number, which would just be 1. Take a second, plug in a 1 into your calculator, hopefully, for all the x's right there. When I did it, I got out a 12 for the y value. So 1 comma 12 would be the maximum value. If you checked your answer in the back of the book on this one, it would actually just give you the y coordinate. So I don't know, I kind of like to put the whole vertex though. It's nice to me to have that complete point there. One more real quick here. This parabola would be a smiley face parabola. And so it would have a minimum value. Wouldn't have a maximum value because on each side it would keep going up clear to infinity as it got farther and farther out. Okay, so we need to find that minimum value. That would be the vertex. So negative b over 2 times the a number, 2/5. Might have been a while since you divided by a fraction, but if you divide by a fraction, you just multiply by the reciprocal. Copy dot flip is what your secondary math 1 teacher might have taught you. So that'll be 25 over 4. If you don't like the fraction, you could also get the decimal equivalent of 25 over 4. When I went through and I plugged a 25 over 4 for all of my x values, back up there, I totally messed that up. It's not 25 over 4, it's 25 over 2. I don't know where I got that 4 from. So 25 over 2, as a decimal, that would be 12.5 if you like it better. When I plugged that in for my x values into my function, I got negative 4.25 for my y value. So that one's a little bit trickier just because of the messy numbers. You don't get nice whole numbers for your answer there. Okay, last but not least, in class, we're going to bust out some graphing calculators and let them help us do this. I am actually not going to talk about this a ton on the video. I think I need to be next to you, actually showing you where the different buttons are on the calculator. You might have used a graphing calculator quite a bit already, and you might know how to do this. But just talk to me about it when you get back to class, and we will do it then. If you really want to do it before you get back to class, just use desmos.com. It'll graph these parabolas for you, and then you can just hover over the point where the vertex is, and it will show you the maximum or minimum point. So I will either let you use Desmos and do that on your own, or when you get back to class, I will show you on your specific brand of graphing calculator how to do it, how to find the minimum or the maximum point of a parabola. Desmos is also, it's a mobile app. So on the App Store, go and just search Desmos, and it's an app on your phone, which is sweet. So there's your assignment. I'll also type this into Canvas. As always, you guys are awesome. Thanks for watching. Hopefully you're back in class soon. Have a fantastic day.